All right, welcome to Trigonometry word problems. All right, we're going to start with a problem here. It says, to reach the top of a hill that's 1 kilometer high, one must travel 8 kilometers up a straight road that leads to the top. To find to the nearest degree the number of degrees contained in the angle that the road makes with the horizontal. All right, so basically you're at the top of a hill. It's 1 kilometer high, which is here. So this is 1 kilometer. One must travel 8 kilometers up a straight road. Well, if you're traveling up a hill, you're coming up this way to the top of your hill. So that's 8 kilometers that you're going up the hill. And we want to find to the nearest degree the number of degrees contained in the angle that the road makes with the horizontal. Okay. So we want to find this angle here that the road you're traveling, the 8 kilometer road you're traveling, makes with the horizontal line, which is here. All right, this forms a right angle, okay? Because although hills look like hills like this, there is a horizontal component and there is a vertical component underneath here that engineers look at to determine how much they can angle that hill so the cars can actually travel up, okay? So this is our pathway up, 8 kilometers, 1 kilometer here, and we want to know this angle here, which is x. So when we look at this, with respect to x, we have an opposite side and a hypotenuse, so we have to use sine. So we're going to say sine of x equals to 1 over 8. Now to find an angle, you have to invoke the inverse function. So x is equal to the inverse sine of 1 over 8. And you take out your calculator, make sure you're in degree mode. And when you solve for x, x is going to be approximately 7 degrees. All right, because it said to the nearest degree, so make sure you round to the whole number. All right, now we're going to look at another problem. Okay, it says, at a point on the ground 50 meters from the foot of a tree. So here's our tree. 50 meters from the foot of a tree, right here. So the angle of elevation of the top of the tree contains 48 degrees. Well, the angle of elevation to the top of the tree is from the line of sight of the tree, which is parallel to the horizontal ground, okay? And that angle of elevation is 48 degrees. Now, the reason it's drawn this way on the left-hand side as opposed to making the angle of elevation go this way is because we're 50 feet from a point on the ground that is to its right. So that angle of elevation continues all the way up, okay? If we switched our tree to be over on this side, it would go from 50 feet up this way, and its angle of elevation would be here, okay? So either way that you do it. All right, so we're going to focus on this problem right here. We know that the angle of elevation of the tree, okay, going up this way with its horizontal line of sight is 48 degrees. These are vertical lines, so this is 48 degrees. And since these are parallel lines, these are alternate interior angles, so this is 48 degrees. So what you notice is the angle of elevation of the tree is the same as the angle of elevation of the point or person that is 50 meters from the base of the tree. All right, we want to know the height of the tree, so we don't know that. So very simply, if we take out a right triangle here, okay, because remember, trees are vertical and we have a right angle formed, okay? This is x for the height of the tree, 50 meters for the distance from the bottom of the tree, and we have 48 degrees right in here. So since we have opposite and adjacent side, we're going to use tangent. So tangent of 48 degrees equals x over 50. When we cross multiply, x is going to be 50 times the tangent of 48 degrees. Now you're rounding to the nearest meter here in this case, otherwise you would round to the 10th, but if the directions say otherwise, make sure you read that carefully and do what it says. So when we solve for x, x is approximately 56 meters, and that would be our height of our tree. All right, next we're looking at a ladder. Leans against a building and makes an angle of 72 degrees with the ground. All right, so let's build it this way. This is our building. This is our ladder. Okay, it's 20 feet. It's leaning against the building and makes an angle of 72 degrees with the ground. Well, here's the ground. Buildings are vertical, ground is horizontal. So we have a nice 90-degree angle here. And the 70-degree angle is right here that it makes with the ground. Okay, we want to find to the nearest foot the distance between the foot of the ladder, right here, the bottom of the ladder, that's what that means, and the building, right here. So we need to know the ground distance from the bottom of the ladder to the bottom of the building. Okay, let's see what we have here. 20-foot ladder. All right, so we don't need to know anything about how high this rises on the building. We just need to know this. So we're looking at an angle of 72 degrees, and we have an adjacent side, and we have a hypotenuse. So we're going to use cosine. So the cosine of 72 degrees is equal to my adjacent side of x over my hypotenuse of 20. So when we solve for x, we're going to get x equals 20 cosine of 72 degrees. Remember, all work should be shown. And when you solve for x, it says to round to the nearest foot, so it becomes 6 feet. Okay, and that's how far the ladder is from the ground when it leans against the building.